In every era, there is a need, a spark, an instinct that brings us together to imagine and to innovate. This hasn't changed. What's possible has. We create technology that makes our world better. Ideas that move us, empower and connect us. But great ideas cannot thrive alone. They need to be shared, challenged, refined. Through our insight and collective curiosity, we advance and grow. New solutions, new directions, new answers. We do that here, together. This is the age of connected intelligence. Welcome to the IQ era.
Hello everyone, welcome to the panel, The End of Automobile as We Know It. My name is Tobias Scheiderbauer. I'm a partner with McKinsey and leading our topic around connectivity within the McKinsey Center for Future Mobility. What we are seeing at the moment in automotive is there's a big change coming. And we are seeing the rise of software-defined vehicles that tremendously is changing the environment as we know it. It's really about looking on a different domain, whether it's connectivity, cockpit, and also autonomous, and partly they're also converging also on the hardware side. So we're already seeing like first solution in terms of single SoC for cockpit and also autonomous. We see also new requirements for then on the software-defined vehicles in terms of what needs to be happening and also what is the upgradability of the vehicles that is required. In addition, we also see new competition that is joining, whether it's like then also from Asia, also from newer disruptors, where also then the automotive industry, basically the incumbent OEMs, are heavily challenged and also trying to cope with this. All of that means also that on the regulatory side, there are also questions arising. And this is the topic that we want to discuss today in our panel. I'm very happy also to have you all here and that you're showing up so frequently for this. So I hope that we deliver also on the respective curiosity. Let me introduce you to the panel. And let me start with Luciana. She's the Chief Legal Officer of Lennior. Very happy to have you. Then we have Suman Zera from Harman International, the Global VP for Portfolio and Innovation. And Udayan, Senior Fellow and Chief Architect of Intel. Very happy to have you. And last but not least, Dave Weather from Physics XX. Thank you very much.
Hello.
And maybe let me start with the topic around connected car. So Luciana,
Yes.
From a global IoT and regulatory standpoint, vehicles are now roaming data centers and crossing borders daily. Who ultimately governs this actually and who needs to do it?
Okay, so Tobias, there is not an easy question to this one. There is not a one size fits all. There is actually an interplaying of different regulation. I mean, to start with, like type approval regulates all within safety within the car. So from steering, braking, to even like over-the-air updates. But as cars are evolving and the use cases are evolving, we have now, I mean, cars provide internet access services or infotainment, call assistance. And this is like subject to telecoms regulation. And then, I mean, regulatory requirements such as like lawful intercept, licensing, or like notification regimes apply. And yeah, and then as we know, as well as you said, like cars, they are like data centers, actually connected data centers, and they can change behavior overnight. So then you have like horizontal regulation around data that applies as well at the same time, like on like privacy, AI, and cybersecurity. So it is really like a jungle of a lot of regulatory requirements that the OEMs have to consider. And they have to take a strategy. They need to understand, I mean, what are those requirements around the world where they are deploying services to be able to make it at a scalable level as well.
And do you see that the regulatory framework is now in place for software-defined vehicles, or is there anything missing or anything that's still needed basically to do that?
Yeah, I think it is very difficult for regulators to keep up with the use cases because they will evolve much quicker than what the regulatory environment can keep up with. So if you think, for instance, as an example in Europe, where you have like the roaming regulation, when it was put in place, it was actually a regulation to protect users traveling within the union. And later, it included also M2M. So, and today, permanent roaming is allowed or like tolerable in most countries, and it is actually serving very well for certain use cases in automotive. And then as those use cases, they evolve, then you have, again, like cars that provide internet access services, and those services are more subject to either like licensing in some countries like Singapore, Thailand, or notification in other countries as well. And notification in Europe, you have to like notify. And I would say there is a fragmentation because the notification system was envisioned to be very easy, but it is not. And that influences how, I mean, the OEMs are designing their solution.
Okay.
Then I would also like to say when it comes to cross borders, you know, and data sharing, it is also a very important topic for monetization. I would also say that when it comes to privacy, there are, at least in Europe, very good and robust, mature rules where you can transfer data under certain conditions, of course. And then I think what we see now emerging, which is a challenge, is more industrial data generated by the car. And we can see a tendency in some like markets, I would say Middle East and others, where there is a demand from the regulator to keep data localized and processed locally and even available to the regulators. And this is because of security reasons and of course, the geopolitical evolution. And this is also a very important factor because it influences how the solution is going to be designed and whether OEMs can scale these solutions or not.
Okay, very good. Thank you. Suman, Harman sits at the heart of connectivity in automotive. When you look towards like the incumbent OEMs, do they really envision themselves as tech players of the future, or do you see them rather as being set up still as a manufacturing company?
That's an interesting question and the way to put it. I think the world, as we see it, we're currently going through this transformation and being, like you said, being at the intersection of where the industry itself is facing certain tailwinds. Electrification, you mentioned it in your opening statement on software-defined vehicle architectures. To me, the OEMs still pretty much own and control the vision in terms of what the car has to do. And then also owning the design and the architecture, not just from the brand ethos, the customer experience, but more importantly, also they have the regulatory obligation, responsibility and the accountability to make the user and the riders on the road safer. However, because of this transformation, there is also a need for a new way to industrialize these experiences. I think of more of a platform era that is happening. This took place maybe in mid 2000s to the mobile phone industry. And I see we are now going through the same sort of, let's say, evolution or disruption where pre-tested, pre-integrated software platforms. And I see the OEM's role, and we can debate about it, is going to be more focused on digital platform orchestrators. What that does not mean that all of them are going to build everything from ground up. And I think this is where the power of ecosystem comes. This is where someone in our shoes as an integrator of various different things that we bring together. I'll just give maybe a couple of examples. The new software-defined vehicle architecture, which is all encompassing, whether it's EE architecture, zonal compute, central compute. As you think about the different dimensions, you have AI now taking hold. We see a need for a purpose-built LLMs. You have the connectivity stack. You have ADAS stack. You have intelligent cockpit stack. You have safety stack. So the moment you start piecing this together, you quickly realize I don't see OEMs are aiming to become the next Silicon Valley software tech company. I can say that because I am in Silicon Valley. We have a lot of OEMs who are actually working on some of these things, but where they are really changing and revolutionizing is how do they orchestrate these different pieces? Because I think this is what will propel us forward to get this adoption at scale.
Okay. And how do you see that the role of tier ones is then changing? I think like there's also like a couple of news that you brought out in terms of productized approach. So can you elaborate a bit in terms of how you see this is like changing and what are also answers that you need to give as a tier one?
Absolutely. Like I said, OEMs are looking very much onto what are the user experiences eventually and how the core competencies are focused on managing the life cycle throughout the ownership model, right? From total cost of ownership. And as you start looking at it, they seek someone in the shoes of Harman. Can you offer us pre-tested, pre-integrated platforms, products that can help them accelerate time to market, lower the ED&D or non-recurring engineering cost? So from Harman, what we have been doing over the last several years, and I'm proud to say this, we've actually taken a lot of complexity by pre-testing, pre-integrating. So if another team is putting, let's say, a smart cockpit or a central compute unit, my team is responsible for connectivity. We have various software products. We have telematics control unit. Each and every one of that product actually can talk to each other. It's interoperable. The northbound, the southbound API structures are shared. We believe in eating our own dog food. So when you come over to our booth in Hall 2, these products are all sitting inside the car. So everything is stitched together like stringing a necklace of pearls, right? And I'm proud of the pearls that I put to the table from a division perspective. But this is where our product mindset to shift left and give these OEMs a chance to focus on what they need to compete with not just the cost pressures, but also the features that are being rolled out from some of the Asian OEMs and how that is affecting the industry at large. The pressure is on.
Yeah, very good. Then I would say, like, let's move a bit forward also towards networks. So Udayan, you have architected virtualized 5G infrastructure and are shaping next G standards.
Right.
For autonomous mobility at scale, what must fundamentally change in the network architecture that it really works?
Yeah, when we started in 3GPP 5G specification, one of the critical element of that was mission critical IoT. So essentially, a mission critical functions interconnected. and low latency communications between them. So we devised a lot of technologies, things like ultra reliable low latency communication is part of 5G and stuff. But what happened, if I step back, I mean, connectivity in the car is nothing new. I mean, back in 2017, I bought a Tesla. Yes, it has always been a 4G connected and streaming elements, music, and whenever they were getting into an Wi-Fi system at home and others, they were using that to download the software, upgrade and stuff. But where it becomes more important, and this is standard connectivity, you don't need fancy 5G low latency features for that.
Yeah.
But then when you became more like FSD, full self-driving now, although some of the units that Suman talked about, they're all processing within the platform.
Yes.
By the way, Intel participates there as well. We have an Israeli company called Mobileye that builds a lot of this and collects data and a lot of software being generated there. But a lot of processing happening in the platform itself. They are not depending truly for some of the mission critical on the network. But what is now changing is that some of this processing elements is going to the net. I mean, in China, we have use cases that we have actually trialed where you have a road that they define. It's a government support there. Every rest area stuff is becoming a network and edge, and you're offloading some of the processing to actually bring back and a fast.
Yeah.
So the more there'll be dependency on the network, not just on streaming or connectivity or just software download, but truly getting something processed and bring it back, that will basically use the network in a more critical fashion.
Okay.
Many of these companies have started looking into this. In 6G specifically, we are even looking into more mission critical elements. Some of the ISAC sensing stuff requires really, a lot of the pulse communications require really very low latency communication, even lower than URLLC. So we are having these use cases in mind, you know, because this becomes nothing but a software platform.
And where do you see the bottleneck today, or maybe like in 5-10 years? So what is the way ahead in terms of like what needs to be looked at to get this right?
Yeah, I mean, so this whole autonomous vehicle things has their fits and start. I mean, you have new players like Lucid, Teslas of the world are doing a lot of innovative elements, but you also have companies like GM and others had platforms taken back, you know. The hybrid is in between. But true autonomous elements also require some of the standard stuff that you talked about, interoperability. I come from the United States. We don't see that worry too much, you know, but again, sharing the data, you're frequently sharing all the data with the manufacturers or whoever the software providers, and is there a privacy element in there? So those things are getting into play, and if the accident happens, who is at fault? Fully autonomous. That is a huge discussion in United States about how is the insurance going to pay to whom and who is at fault, you know. So a lot of these models are changing. So it will take time. It's not just technology, but the whole idea of, imagine that when we used to graduate, the first thing we used to do is buy a car. I mean, now my son graduated last year, he got a job, but he said, I don't bother about this. I can just use that, call, so there is no car ownership. That's fading quite a bit. So a lot of this insurance model, privacy, connectivity, those things need to get addressed, interoperability. Technology elements are there. I have a feeling that there is always going to be the mission critical processing will be in the platform, the software-defined platform, multiple different modules. But you cannot leave all the processing there, that there will be edge processing and there will be fast communications between this. So a lot of these other aspects of it needs to get sorted out when it fully becomes a full autonomous in a vehicle.
And you just talked also about in terms of like that demand is shifting also from the customers is shifting. But I mean, what we also see is like a continuous change in the adoption curves of autonomous also in other things.
Right.
So how does this influence then also infrastructure investment needs? Because I mean, if like in the last cycle, basically when you like anticipated autonomous to be there already, then you pre-invested too much.
Right.
So how does it influence?
Yeah, so actually it creates more demand for the networking and autonomous side of it. A standalone car that millions of cars in the road doesn't do much. You just update the map or whatever. But as you truly start depending on the network, your 5G infrastructure, as a 6G infrastructure coming in 2030, that becomes very critical. So there is, even though when we define 5G, as I said, massive IoT and mission critical IoT was one of the three cornerstones. There's nothing mission critical about what most of the 5G being deployed at this point. It's all mobile broadband. But when these things are taking hold, more and more autonomous car there, I mean, ownership aside, either it's owned by set of companies that are actually like Ubers of the world or people, the network becomes a critical element of it. So that's what, if you talk to operators here at Vodafone, Telefonica, or even US in AT&T, Verizon, they look towards that as creating additional services beyond just connectivity between you and me and the streaming. So the future is bright for the network, but we have to see how this thing evolves. And we have to shift gear in many times. If certain things are not being addressed in the spec, then we have to go there and do it. Then it's not just 3GPP. There are O-RAN, there are tapes, there are AI RAN. There are AI element services coming into play to predict, what the road condition is going to be. Those things are already getting there. So those use cases means more services. So it's all good for operators. They're hungry for new service.
Very good. Maybe, Luciana, if now vehicles depend on this network intelligence for safety critical decision, as we just heard, I mean, that also then fundamentally changes a bit the liability question towards then telcos, operators. So how do you see it, and are they really ready for it?
Yeah, that's a good question. Yes, the models, they are evolving and the networks are becoming more intelligent, and there is more requirements for providing or enhancing security. So, but I don't think that telecom operators are fully ready, to take ownership or like to increase liability yet. At least I feel that, as the model will evolve and the networks become more a part of the decision making for the safety features of the car, then it becomes this becomes less of a connectivity service and more like an integrated part of the security or the safety system of the car. Then, of course, it is natural that it starts a discussion between the ecosystem about maybe sharing liability, right, or sharing the responsibility. And then I think the models will evolve for, liability being distributed to the party which is actually providing that safety feature. So that party will then be liable. But I think we're very much in the infancy and these discussions are starting. And my point of view is that for now, we need to still keep all the safety decisions on board the vehicle. You should not put safety decisions in the network. So they should not be really the braking pedal. They should be in the car.
Yep.
Yes, indeed. I mean, that would be becoming very difficult in terms of also different asset levels.
Yes.
In terms of like what you need to also adhere to as tier one supplier, as an OEM. I mean, that will not shift. Nevertheless, I think for me a bit the question is, so what will be also the requirements from automotive players or OEMs when it's like always called automotive grade, that like in terms of what to bring in, that like new requirements are brought up also towards telcos and operators when you move towards the safety critical element. And is this shown already in full flow, the discussion, or will this happen only a few years out? I think that's a bit of where I think there will be like deeper discussions needed to like move ahead and define this clearly.
Correct, together with the technology, right? As the technology evolves, then those discussions, they need to evolve as well.
There are a couple of, just to add to that, there are a couple of standard bodies purely focused on automotive and connectivity. I mean, they are feeding some requirements also to different suppliers through GSMA bodies as well as to our 3GPPs. So there are, some of the bodies, there are automotive specific bodies that are helping us.
Yeah.
Someone shipping.
Very good. Then let's shift a bit and move also towards AI. So Dave, you come from Formula One, and in Formula One, milliseconds are deciding for win or lose, basically. How does AI native engineering change vehicle development cycles, and also what successes do you already see? And is there real value behind, or is this just like a dream that everyone is dreaming a bit about?
No, it's a great question. So what we see at Physics X is introducing an AI native engineering stack really transforms the vehicle development cycle. And I like your F1 analogy, so I'll stick with it. It's not like a mid-season update. It's like the introduction of the ground effect car. Why is that? I think that the superpower of these models is their ability to give near instant prediction for simulations of complex multi-physics, which in traditional numerical approaches would take you hours or even days, and that superpower runs right across the development cycle. So if you sort of think about the design phase of a vehicle, you can use these models to take days out of every design or concept iteration. And also, these models, you can train them on simulation data, but you can also train them on real-world data. So, you bridge that gap, and suddenly you remove a lot of the need for sort of expensive and time-consuming physical testing. Then moving to manufacturing phase, you can put these models in the hands of manufacturing operators. You can get real-time prediction of the outcomes of casting processes or other manufacturing processes. So you can really start to kind of steer the quality of your output. And then when we think about on-car, these models create very high fidelity digital twins that can be used to drive complex control optimization, engine systems, and battery systems. And I guess, particularly relevant to today's discussion, these on-car models, they can evolve and they can learn from the data not only collected from the sensors on the car, but also kind of through federated learning at fleet level. And of course, that relies on having the right communication between the edge compute and the cloud compute. And with the evolution and the sort of improvement of these models that you can then feed back into the design process, suddenly your vehicle development cycle follows the life of the vehicle, and your vehicle very much becomes an evolving product. So it really is a very fundamental shift.
But does this now mean that our incumbent OEMs can really shorten their vehicle development timeline tremendously, or what other boundary condition do you see that you need to get right to really do this?
So yeah, I think the short answer is yes, but going back to your value point, to really extract the value from this technology, we need to think about it not just doing the same thing faster, but actually thinking differently about the whole problem. For example, these AI models, they don't need the same level of expertise to run as a traditional simulation. So, they can be driven by a design engineer independently, and suddenly, the communication between design engineer and simulation expert starts to collapse. And then, these models are also exceptional at solving for multiple physics. So, for example, if I wanted to design an engine cooling component, and I want to solve the aerodynamics, the structures, and even the casting performance of that component, I can now, with these models, I can now do that within seconds. Okay. And you can imagine how much that collapses all the interactions between different groups. So it really is a completely different paradigm. And I think we need to think about it in that way. And if we do, then certainly what we see is you can massively collapse the whole development cycle, and see reductions in the order of 50%, which is exactly what the OEMs need to be looking for to compete with the disruptors.
very interesting. I think that you also mentioned like one topic in terms of like you need potentially other expertise of the people. Does this also mean like you need to rethink your organization, processes, and basically really like rethink everything around this? Because I myself, of course, like saw also several pilots that are not delivering the impact because it's not thought end to end at the end.
Yes, certainly that's what we see, and I think you touch on it with a pilot is not going to give the full value if you don't sort of step back and see the bigger picture. And increasingly, we're seeing our customers recognize this and think differently about how to deploy their engineers and their designers, and it's certainly not about losing the need for your simulation specialists, but your simulation specialists move more to a role of training these models and keeping these models at optimum performance, and then you start putting the hands directly into the designer's control, and obviously you need the front end that the designer can work with, and it's only once you've put that whole end-to-end together, then you really start extracting the value.
Okay, very good. Then I'm looking forward to the shortened development timelines at the OEMs. Udayan, you are developing domain-specific LLMs for network optimization. Could AI eventually manage vehicle-to-network orchestration then also in real time?
Yeah. Right now, what we're doing, we took a open source LLM 7 billion parameter Mistral, actually. It's a French company. So their LLM, and what is we are stripping few things off and then doing a domain specific for telcos. Like we're feeding them a lot of 3GPP data and a lot of simulation data. My own 3GPP team has generated a lot of data that I've got from operators also on their drive test that they can freely share. They're very nice on that way. So fine tuning. But the funny thing is that fine tuning portion happened in the hyperscaler as one time or a couple of times deal. But then the whole network, and this LLM was used for root cause analysis. It was that operators, we are doing this with two operators. Their requirements is it has to be on-prem. They don't even want the prompt to go out. So there are a lot of say my data is my data. So right now that is being used in network debugging. So first is network debugging and network optimizations, root causes, and then feeding what in the cell center or cell edge, what things need to change, configurations. But you can see that you can expand that to other use cases.
Okay.
Right now it is that, and then deployment, day 0, day 1, day 2, a new function comes, how quickly I can do efficiently and cut down some of the resources that's needed. But real-time aspects of it is not there yet, but this is something certainly you can think of through, that the whole autonomous element of a function, not just autonomous car, but autonomous robotics elements of it, physical AI aspects of it. There are a lot of operations and management aspects of it, and quick debugging, quick configuration changes, quick actions. So this is where AI models, not just LLM, but various AI models can actually play a big role.
Very good.
And those will be just to add to that, it will be most of the cases, you may depend on hyperscalers for fine-tuning or training or sometimes getting additional data, but these will be in the edge compute elements of it, the way things are moving in operators.
Okay. Very good. Now we talked also on edge, on infrastructure. Suman, in a connected mobility, we don't just have the edge. So we have multiple edges. From a system architecture perspective, how should OEMs decide on the near edge, on the far edge? So which applications should run where?
Maybe we calibrate the terms for the audience, yeah? I think for vehicle edge, we're trying to compute and process everything inside the vehicle. And to me, that is associated and continues and will continue to associate with mission critical, safety critical workloads. Then we have something called near edge, which we could also say telco edge. This is akin to MEC for those who understand the term in this industry, multi-access edge computing. Here we are talking about use cases and workloads that pertain to cooperative perception, V2X, traffic management, how the vehicle and the infrastructure interact. And the far edge, this is really the agility of your cloud computing. And I think both of the folks here have actually mentioned, Udayan touched on this, such as Dave as well. When you think about big data analytics, when you think about AI, federated learning, digital twinning, some of those do need that powerful machine. These are power intensive, power hungry, compute resource intensive workloads. The question isn't that should one be the best choice. I think the question is going through a design architecture that prioritizes what works best given the nature. And I think what comes to mind is maybe 3 or 4 dimensions through which you filter this through, and your design architecture has to process this. One is, like I said, is it a safety critical or a mission critical application? What is the latency tolerance that you can live with? If we are talking about a case of autonomy, I'm sorry, I cannot wait for the network to give me that QoS. I need it now because my life depends on it. So the latency is part. The other thing is, and I think you touched on it, Luciana, data governance. I think in all the work that I've done in the last decade plus, this is one area that keeps coming back, the stewardship of data. Where is the data being collected? Where is the data being processed, analyzed? There may be cases where you can still process everything within the vehicle, but I think the network intelligence plays a role because I would still want to share the metadata or the inferences because I've made a certain hypothesis that this is what I think based on the sensors that are telling me, perception stack, ADAS, V2X. But was I good with my hypothesis or not? Because I needed a lot of processing power. And where the vehicle and the designer has to contend with every ounce of compute power is a joule. Sorry, I'm going back to my school days. Every joule is wasted of what a potential driving range would have been. So I'm always making that arbitration. What should I process here? Is it safety critical or not? And eventually it comes to cost. There is a cost to offload all of this. I'm sure she will love to capture that part of the value chain. But there has to be an economically viable way for how this translates into scale. We have seen a lot of effort in the last 10 years. I was bleeding blue a few years ago. Udayan knows this. The challenge is always not what can be done on a test track, on a lab. I think that's all good. To a normal consumer, I need to be able to have safe, secure, smart, and reliable experience, right? It cannot work just on one particular freeway and not on the other one. So to me, these are things that as an industry, we have to come together. And a big portion of this is also related to the regulatory understanding. You cannot design something that is kind of a moonshot and then realize, oh boy, I didn't think about how does the regulation come in the picture. So it's dud on arrival.
Okay. Very good. Maybe we open it also for the audience. So are there any questions? So we have about time for about 2 or 3 questions. Yeah. Anyone? Should be almost ready.
Great. My name is Drew Clark with Broadband Breakfast. Fascinating discussion. From the on-the-ground reality, could we just get a sense of timelines and how long this will take and where? That is to say, obviously this is a lot more than autonomous driving, but let's just start with that. Like, how soon will we get it everywhere in particular countries? Who's ahead? Who's behind? Is the bottleneck, regulators being slow, or is it the industry not kind of working well together, given the complexities of the ecosystem? Just from someone who's not steeped in this aspect of the industry, would love to just get some more perspective on how soon do I have to wait for my automatic vehicle?
Maybe I can offer my 2 cents. Great question. I don't have a crystal ball myself, but we already see, and I say this from a Harman perspective and also as a constituent of the state of California. There are already people movers that are actively operating in the streets of San Francisco, Sunnyvale, and other parts which are fully autonomous. Is it a question of technology? Is it a question of integration and how the ecosystem is working or lack thereof? I don't think so. I think the industry recognizes that the power of this ecosystem is what brings this technology to scale. And if I step back a little bit from a fully autonomous vehicle to pseudo-autonomous, let's say L3, L3+, we're already, as Harman, as a technology provider and integrator, we're already supporting quite a few OEMs who are aiming at bringing L3, L3+. The conundrum is more around where some of those decisions take place. If we could fast forward in the time continuum and we have networks that give me a slice that is dedicated to some of this with a dependable and a reliable quality of service, which I see the promise in 5G already, not so much in the previous generations. It was a very different architecture. Some of this is happening. There are different fleet and platooning with commercial trucks that is taking place. So there is pockets of industry that is already demonstrating this. If you step into more a controlled environment, let's say ports, institutions like hospitals, university campuses. I spend a lot of time working with China on smart city and working with their National Development Reform Commission that sets these 5-year plans. This was something that was happening even before the turn of the last decade. So things are happening. The question is, when do you and I, as a consumer of this technology, see it as a mass scale? I think that is still work in progress.
Good. We would have time for maybe one more question. Yes.
Hello, everyone. My name is Mohan from Reliance Jio in India. So true to the theme of this session, end of automobile, I was super excited because I already don't perceive automobile as an automobile anymore, but I perceive it as my third living space. I spend most of my time in office, home, and the car, in the traffics going to office and coming back. But I'd like to draw attention and seek your views. What does all this mean for an end customer like you and me? We all drive cars every single day. But the fact of matter today is when I'm commuting in my car, if I want to do a banking transaction, I don't do it on my car. If I want to place an order on my online shop, I don't. I still pull out the phone from my pocket, sitting in the car and doing it, right? But I know we as an industry, all the tech, automotive safety, security is okay. I think we are there, but we are still not there in terms of what it means for the end customer, right? And it's still a long journey ahead, right? Globally, we are still not there. But yeah, any views on this? So I'm just going back to the title. I would love to see the death of automotive. I see my car as a super form of a mobile phone, as simple as that. Any views, please?
I can try. Nice to see you. We do a lot of work with Reliance Jio and others. Thank you. See, the first order of function of automotive and death is, keeping that aside, is still taking you from one place to another safely, securely, and now in a driverless fashion. Right now, today, not in the driverless, but I have a car that I just type in the address and it will take from my garage to that address. That address will be somewhere, 50 miles or whatever away. So there, as he is talking about some of these level, these are levels of autonomous elements are there. But at the end of the day, you're right. That platform is nothing but just like your mobile phone, another EV type of platform. So can you natively do your banking elements of it? Yeah, you should be able to. In fact, connectivity today is being provided to some of these car manufacturers. You can, if you get to Lucid and some of this, you have very high stream connectivity that you can actually tap that into to do certain things. But right now, it is more about the autonomous nature of the driving aspects of it, and what does that mean, and this becoming nothing but another software vehicle. It's a totally different platform. Doing banking, transactional elements. If you are actually doing inside the car with your EV, you're still, in a mobile fashion. Things are moving. You're doing it. So instead of that, if you want to do that with your car as a mobile, you should be able to do that, but it's just a matter of time. You'll have to figure out a way of communication. So it will be a verbal communication, say, do my deal, do book this, do that. But right now, I can talk to my car and do, stream this, stream that. So why can't I do, check my bank balance? So you should be able to do that. But it's just how much secure you will feel. Safety, security, and all of this is not just on the driving aspects of it, but this transaction also, it takes time. But technology is there. I can tell you this.
Maybe.
Yeah, I think to just piggyback on this, it's a wonderful question. And the question that most of the OEMs around the globe also reflect on. Is this happening in parts of the world? I invite you to travel with me to Shanghai Auto Show.
Exactly.
And you may have a different way to think about, is my question still relevant or valid? The question is, how are these pieces getting stitched together? Technology is a means to an end, but somehow we try to make this in the forefront. It's the use case, it's the experience. Technology should really be hidden in the plain sight. You shouldn't have to worry about any of what you may see. So the question is, there is so much friction. This is an area where I believe, again, speaking from Harman perspective, we're trying to solve the problems of tomorrow today, but not a plug, but the challenge that we are taking on ourselves is thinking like a futurist. What would society be 10 years from now? Not what Harman should do, but what would society be 10 years from now? How would people, the behavior, the psychoanalysis of the buying behavior, interacting behavior. Personally, for me, I always draw inspiration from the movies like Iron Man, where you have Jarvis, or those of you who are a fan of Minority Report. To me, that is the world I want to be in. This is the world that I want to be in, where the car knows me. There is a seamless connection between my smart home, my smart work, and the vehicle on the go is a space that is on the go, fully digital connected. So it doesn't matter which profile do I live in, but the system has to have that intelligence, and it won't happen without the telecom intelligence, the network intelligence, and it won't happen without having the full end-to-end seamless connectivity. So some of this is happening. I appreciate you asking the question and keep us on our toes. But that's what we want to bring to the rest of the world.
Thank you very much. And we are coming also now to an end, unfortunately, of our panel. So big thank you to all the panelists for the interesting and very good discussion, and of course also to the audience. So thank you so much. So we see software-defined vehicles, they are here. It's also really an ecosystem topic. I mean, we also see here on the stage, basically from the different players in the ecosystem, they need to work together to bring this to a reality. And then at the end, I think the last question on what does it bring to the consumer? I think that's also like the proof point which we all see in our daily life. So thank you very much.
Thank you.